Hello everyone, this is S.K. Mehta, presently the President of the Indian Nuclear Society called INS. I wish to welcome you all to this INS series lectures. This series about 13 lectures is aimed to acquaint you with the various aspects of the nuclear energy, its utilization in various areas benefiting humanity, the limitations and the regulatory aspects in safety and protection. One of the main objectives of the INS is to promote the advancement of nuclear science and engineering and technology related to the atomic nucleus and the allied sciences and arts. With this objective, INS has been disseminating information through journals, books, reports, newsletters, seminars, and conferences. These have mainly been to keep the INS members and other scientific communities and organizations well informed about the development in the various areas of science and technology within India and world over. Or it is realized that there is a need to keep the various professionals, undergraduate students, and general public knowledgeable in their respective fields of nuclear science and engineering. For the benefit of the public, some of the important and the common application of nuclear being for power, industrial use, medical diagnosis and treatment, agriculture, food preservation, and various other areas. This lecture series is made in simple language and illustration with the aim to inform the general viewer about the science, engineering, and technology, social benefits of the nuclear, application of nuclear carrier benefits in nuclear and regulatory and safety of the nuclear energy. The presentations are prepared and narrated by experts on each topic in a way that the viewers with no background knowledge about the nuclear science and engineering can understand. Our effort will be to constantly provide information about newer benefits to the society emerging out of the painstaking research and nuclear science and engineers. Viewers are encouraged to comment, suggest, and put forward questions to the experts. The channel of the constructive communication will always be open in INS, which is website ins-india.org.
Welcome all to this wonderful lecture series by Indian Nuclear Society. There are 13 lectures on various topics related to nuclear energy and its application to societal benefits.
Hello, myself Nishant Chaudhary and I belongs from Beam Technology Development Group of BARC. My topic of this lecture is accelerator technology for various societal applications. So, radiation processing is one of the major aspects in the case of our daily life. Nowadays, beneficial application of radiation technology are widespread over all domain of our day-to-day life. It is radioisotope based radiation processing techniques is highly popular in past, but as time propagates and our technology got in the direction of maturity in last few decades, high energy electron accelerators has played a key role in the field of radiation processing as well as basic and applied sciences. Some of them are food preservation to extend the shelf life of food items, medical product sterilization, diagnosis and therapy of cancer, agriculture field, semiconductor performance upgradation, polymer modification, waste treatments, security as cargo scanning applications, and of course basic research and developmental activities. Keeping in the mind the broad application of accelerators, BARC has taken up an elaborate program for designing and building electron accelerators to cater various societal needs. In this reference, a center named Electron Beam Center has been created at Navi Mumbai Kharghar for to take the developmental activity in the direction of electron accelerator program. First, I come to the outline of my talk. In initial slides, I will discuss in brief about the accelerator. What is an accelerator and what is its history? As we know, the requirement is mother of invention, and how the concept of accelerator has been originated in scientific community will be discussed in brief. How it works means how accelerator works, and most important, what is the purpose of accelerator means what is the field of applications of accelerators in our actual life, like food preservation area, medical, agriculture, environment, industry, security, power generation, and basic research. And at last, I gives few glimpses about the footprint required for a accelerator facility. So I come first, what is an accelerator? So it is simply a device which increases the kinetic energy of a beam or charged particles. Like in this figure, there is a 2 points where the potential difference has been created by some means, and a charged particle is projected between these two potential differences, and this charged particle will start accelerating towards the respective electrode, and so this is called acceleration. But one word I have used is beam. So what is a beam? Basically a group of particles of same type of traveling together in same direction and having around the same energy is collectively called beam. Brief history of accelerator. Origin of accelerator started from research applications, and in first 1919 Rutherford got the first nuclear reaction using natural alpha rays. At that time he felt that he requires many MeV energy to study the atomic nucleus, and from there is limitation of radioisotopes that not up to a certain MeV more energy can be achieved. So some artificial manner must be implemented so that high energy alpha particles or charged particles will get to break the nucleus and study the details about atom. And in this direction, in 1924, Ising proposes the acceleration using a variable electric field between two drift tubes. So he is called father of LINAC, means linear accelerator. In 1931, Livingston demonstrated the cyclic accelerator principle, which is called cyclotron, and it achieves a big milestone after some years. 1932, Cockcroft and Walton, a big name in the field of accelerator, built a 700 kV electrostatic generator and broke the nucleus of lithium with proton 400 kV. He got Nobel Prize in this work in 1951. And the same year, Lawrence produced cyclotron-based proton accelerator just after few weeks of Cockcroft-Walton experiment. Lawrence also got Nobel Prize in 1939. So these are the brief history of accelerator, for how time frame has been created to evolve the accelerators. Method of acceleration is electric field contributes in gain of kinetic energy as it applies force along the direction of motion. So here if I project a charged particle in this electric field, it gains some kinetic energy. But magnetic field is applied not in gaining kinetic energy, but to bend or focus or turn the charged particle. So if magnetic field is applied here inward to the plane, then it bends the charged particle and again re-project in the same electric field, and in each time we saw the radius is increasing because in each step particle will gain energy, so its bending radius will increase. In this way, magnetic field is also utilized in the area of accelerator by bending to bend the charged particle or to compress the charged particle. Suppose this is accelerator and our utilization part is here, target or to utilize is here. So we apply a magnetic field which bends the charged particle through 270-degree angle. So in this way, both magnetic and electric, both fields are required to run successfully the accelerator. So method of acceleration, there are only two methods of acceleration. One is direct acceleration, another is indirect acceleration. So in this slide, I will discuss little bit about the direct acceleration. The direct acceleration is very simple. There are two electrodes having some potential difference created by a source, and if we project a charged particle in this region, the charged particle will move from one electrode to another electrode and gains the kinetic energy. This is called electrostatic acceleration principle or direct acceleration principle. So here we can see that 2 points from between which the potential difference has been created and particle will gain energy. Again after some time the particle will face the potential difference and get the energy, again get the energy. So based upon the number of steps, the particle will achieve the energy as per the requirement. But there is a limitation. We can't go to create the potential difference between two terminals directly infinite. So to because the unavailability of insulating medium between these two electrodes, and this is the reason for direct acceleration principle we have not gone beyond tens of MeV like 20 MeV or maximum 25 MeV. Also this creates a bulky structure. Structure is very big. So the concept has come of indirect acceleration principle. What is indirect acceleration principle? Indirect acceleration is of two types. First is cyclic. So in this case, a small electric field is used again and again to get the energy by the particle in steps. So when we project particle in this electric field, it gains energy. By help of magnetic field, we bend it and again reinsert in this. The same electric field is used to create the kinetic energy, to impart the kinetic energy to the charged particle. So as the time the particle moves from one point to another point, the polarity of charge potential is reversed. In this way, the synchronization is important. So with the help of this small electric field, by repeated use of the same, particle will gain more and more energy, and this is called cyclotron. This is the principle of cyclotron. Another way, as in this case, we have projected the particle in the same electric field again and again. But second principle of indirect acceleration is called linear acceleration, and short form it is called LINAC, linear accelerator. In this case, same electric field presented in front of the particle repeatedly like this. Here it is a variable electric field. With time it changes, polarity will change with time. So at an instant the electric field is in this direction and here it is in this direction. Again here between these two electrodes it is in this direction. So when we project the charged particle at a certain instant, it sees potential electric field. So field versus time. So potential electric field and gains the kinetic energy. After this point the particle starts decelerating. So by this, a bunch of particle is created in this region. By the time the particle these bunches are created with the help of electric field and particle moves from here to here, the electric field will change their direction in this fashion. So this arrow will in the reverse direction. So the particle again face the same positive electric field. If the particle moves again, it will see the same positive field. So in each step, particle will gain the energy. So it is the principle where the same electric field is projected in front of the particle repeatedly, and it is linear acceleration principle. Similarly, here the same particle is projected in the same electric field again and again to get more and more energy. And using these two indirect acceleration principle, scientists are able to create accelerator up to TeV region, tera electron volt region. Now, based upon these two principles, direct and indirect, there are many accelerators given different names, but basic principles are the same. Electrostatic generators, Van de Graaff accelerator, linear accelerator, radio frequency quadrupole, betatron, which is a cyclic accelerator, microtron, it is also cyclic, cyclotron is cyclic, synchrotron, all are different names of the accelerators, but the basic principle are one of the three whatever discussed in direct and indirect acceleration principle. Now I come to the point how accelerators are useful to irradiate a product to become a beneficial. So if it is accelerator, the particle gains the kinetic energy and accelerated up to this region, and here there is a magnetic field which acts as a scanner. So the particle area is increased so that it can capture the whole product according to their size, and the particle is projected in this direction, which is z thickness of the product, and is scanning in this x direction, and the product is moving in y direction along the conveyor speed. In this way, this product gets treated with accelerator thoroughly, and this principle is similar to our old CRT television principle, where there is a scanning device, and after the accelerated charged particle will scan over the screen and picture will be created in this picture tube. So like CRT is a safe electronic machine on radiation point of view, similarly electron accelerators for industrial application does not contain or produce radioactive material. It is a safe electric machine. One word we have used is the quantification of radiation. Important thing is it is denoted in terms of dose, which is having SI unit gray. 1 gray is 1 joule per kilogram, means energy deposited per unit mass within the product is termed as dose, which is nothing but the quantification of radiation. I give some glimpses about the in-house developed some electron accelerators, and these are working successfully. First one is 500 keV for surface treatment. This is located at Brit Complex Vashi. 3 MeV for cable and flue gas treatment at EBC Kharghar. 1 MeV for wastewater treatment at EBC Kharghar. 6 MeV, this is linear accelerator for radiography and cargo scanning application. 4 MeV dual energy cargo scanning application. It has the facility to change energy with pulse to pulse variation. This 9 MeV for cargo scanning and neutron radiography. 10 MeV for various agriculture, food and industrial utilization. It is another 10 MeV for the same agriculture, food and industrial applications. So these are working accelerators and in-house developed by BARC. Some applications of accelerator located at electron beam center is given here. This zirconium niobium alloy tube, it is a research application related to the nuclear power components, radiation testing, solar cell radiation testing studies before sending the solar cells using as a matrix for power source in spacecraft, diode characteristic enhancement of semiconductor, is for BHEL, is seed mutation, and biostimulator generation for Agriculture Institute and BARC, food preservation, waste management, wastewater, as well as electronic waste for exotic coloration of gemstone. All these applications has been done successfully, and about all I will show one or two slides in details. First, I come to the fundamental applications of radiation. What is the interaction of radiation with living beings? So, what is the process responsible to preserve the food items or create some mutation in seeds or some cancer treatment or some diagnostic of cancer? So, all these are collectively comes under the interaction of radiation with living beings. So fundamental interaction is direct and indirect. Direct is directly the radiation will hit the DNA present in the cell and damage it. So damaging is by ionizing the DNA molecule or enzyme or any other crucial molecule to damage the cell membrane. These are direct action, but it is minor. Major is indirect action, which is the radiation broke H2O, water presents within the cell, and creates OH radicals, which is highly reactive. This OH radical will react with the vital component and initiate chain chemical reaction, which leads to some mutation. This mutation may be harmful, may be beneficial, depending upon the type of DNA, intensity of radiation, and many more things. So these are the fundamental interaction responsible for the mutation of seeds, cancer therapy, and food preservation, etc. And this interaction is responsible for this successful application of radiation technology related to any type of living beings. This radiation for the processing of food items, Gazette notification has been given by Government of India, and all the food items which are going to be treated with radiation are categorized in 8 classes, and for each class, depending upon their quality and their present nutrients, there is a dose window has been defined. So we must work within these dose window. If I deliver the dose less than this, there is not any gain or solve the desired purpose of food preservation. And if we go beyond this, means higher to this dose range, it may harm the present nutrients in the food items. So a generic class based approval has been notified for increasing the product range for radiation processing. It will provide year-long availability of food stock for irradiation plants and improve their economic viability. So in this way, this defines the safety of food items after treating the radiation, and these data has been created based upon various iterative experimental analysis. Electron beam machine has scope for food preservation. So this machine is beneficial in all the 3 major area of food treatment. One is the low dose and high throughput application, which belongs to the bulk of grains, cereals, and other items like onion, potato, those are seasonal, which requires very low dose and high throughput in the season. So this can be solved by electron accelerators. Second is high dose, high throughput application. In case of packed spices, different type of powders like coriander powder and frozen ground meats. So this high dose, high throughput application is satisfied with electron accelerators. And the third is very high dose application at low temperature. The major beautiful aspect of electron accelerator is it can be processed the food item at ambient condition. So no abrupt increase of the temperature which may possible to decrease the nutrients or provide some harmful impact on these nutrients. So therefore, electron accelerators are very much suitable in the area of food preservation. I will give few things with the help of some photographs that how different food items are processed with electron beam at EBC Kharghar and how its pictorial visualization. So if we are not going to treat onion or potato, we can see the sprouting or some loss of moisture, means some narrowness of these onion leading to the rotten. In this case, avoid these phenomena and store it without any damage. Treatment is required, which is possible with electron beam, and as the photograph explains what is the difference for non-treated and with treated products, onion, potato and mangoes. Similarly, in case of the dry fruits, coriander powders are irradiated. Dry fruits are apricot, quinces, yet the coriander powders are irradiated along with the few dry fruits. Important thing is the microbial counts has been taken at a regular interval, and these microbes are responsible for the damage of these food items. So after treatment, it has been seen that the bioburden remains nil throughout the year, and 1 year storage life is important because in India the most of the food items are seasonal. So if we are able to store it at normal condition for a 1 year, then next season of the food chain will come. So 12-month storage is very suitable for the food safety angle of stored items. These are few photographs of electron beam treated grains like this. It is non-irradiated and it is irradiated, and after irradiation it has stored at ambient condition for 1.5 years, February 21 to September 22. Similarly, some pulses like chana dal, it is non-irradiated, it is irradiated on this date, and till September 22 it looks like as it is. So the difference can be visualized with these pictures of these food items. Now I come to the medical application of electron accelerators or other accelerator also. So first is sterilization of medical product. Electron accelerators are highly suitable for this, to sterilize the medical products like gloves, cottons, catheters, syringe, needles, etc. Second is the cancer treatment, and in cancer treatment part, two types, indirect and direct application of accelerator. Indirect application is to create radioisotopes artificially. It is done mostly with ion accelerators or electron accelerators of very high energy. These isotopes are utilized for diagnosis of cancer and other medical diagnosis also, and the therapy of cancer. Second is direct application, means accelerators with electron beam or ion beams are directly utilized to treat the cancer. Or the secondary beams created by electron accelerator like X-ray generated by electron accelerators are also very popular in the field of cancer therapy, using radiation. These are some photographs of accelerator for cancer therapy. Main feature of this is the object, and the accelerator can be rotated in any direction as per the location of tumor and the decision taken by radiation physicists and doctors collectively. So there is no orientation or any disturbance created to the patient. This is the beautiful aspects of accelerator, as it can be tilted in any direction without disturbing the object. This is 6 MeV electron accelerator for cancer treatment developed by BARC, and presently it is in the testing phase at EBC Kharghar. Now the accelerator in the field of agriculture. First I come to the generation of biostimulator. So EB treatment of ketone and generates it as a biostimulator for sugarcane and papaya cultivation. So what is ketone? It is basically a type of coastal bio waste. Collectively, seashore accumulated bio waste are called ketone, like shrimps, jhinga, etc. All these are collected and crushed, and it became, after adding 1% of acetic acid, like this a gel format. And after irradiating with electron beam with dose of 50 kg, it becomes vial forms. And after that, it can be spread in the field for production enhancement. It acts as biostimulator because these chitosan provide better germination, proper tillering of plant, and regulate the photosynthesis. In this way, it is called collectively biostimulator. So it enhances the production by 1.5 times of sugarcane, and it has been tested in hundreds acres of land with the help of our collaborative institute VSI Pune, Basant Dada Sugar Institute Pune. Now, since it is management of waste, and that's why it is called Swachh Bharat. Second, it is Swasth Bharat because it is a type of organic farming, and its organic material is used as biostimulator for production enhancement. And last is Samriddh Bharat because farmers are encashing their money by increase in the production after this technology. So the slogan is given as Swachh Bharat, Swasth Bharat, Samriddh Bharat for this developed technology of biostimulator in production for sugarcane cultivation. Now it is also enhanced in the direction of papaya cultivation, mustard cultivation, and soybean cultivation also. These are the mutation for different crops. Electron beam is used as a mutant. This is a rice variety generated with help of electron accelerator named ADT45. This rice new variety. So this is normal control seed plant, and this is plant from muted. This is the dose optimization, 200 gray set, 400 gray set. One picture, in the control, the height of the plant is very comparatively high. Almost in muted version, it is small, and the product is also little high. Why? In case of rice, the height of the plant is very crucial, because if height is very high, it is easily fall down in small winds also, and after that its growth has stopped. But in small plants, they can sustain the heavy winds also. So these are the beautiful aspect of these variants ADT45, which is created by using electron beam as mutant. For further details, one can refer these papers. New variety of horse gram and cluster beam which is generated using electron beam, and visualization of this picture of horse gram, this control and this muted variant can be seen. Similarly, in the case of cluster beam, it is parent and it is electron beam treated. So the grouping of fruits in muted version is clearly visible how it is a major achievement of this muted version using radiation technology at electron beam. For details further, these journals can be referred. Now these points is the waste management area and environmental application of electron accelerators. So electron accelerators are utilized in all gaseous waste treatment, wastewater treatment and solid waste treatment. First I come to the flue gas and wastewater treatment. So flue gas case, the SOx, NOx or the gases which are generated by burning the fossil fuels are collectively called flue gas, and these are responsible for acid rain and create various environmental hazards. When we treat these gases collectively in presence of ammonia and moisture, it is converted to useful fertilizer ammonium sulfate and ammonium nitrate, because electron beam first created these OH radicals by breaking the H2O molecules, and these highly reactive OH radical will attack on nitrogen oxide and sulfur oxides to ultimately creates ammonium nitrate and ammonium sulfate in presence of ammonia, which is used as fertilizer. So the harmful product can be converted to useful product by help of the electron accelerator. Similarly, in case of wastewater treatment, the electron beam will create OH radical, and these OH radicals will responsible for oxidation in conversion of dye into biodegradable light inorganic molecules with efficient color removal. So this technique can be used to treat dye water, effluent water, all types. One common thing in both these cases, OH radicals, creation of OH radicals, and which is responsible for further oxidation in both the cases. Therefore, this process using electron beam is called advanced oxidation process. This is electron accelerator located at EBC Kharghar for wastewater treatment. It is actual water flowing below the accelerator. Schematically can be seen by this water jet is thrown in this way and electron is falling vertically downward. This is a scan direction. So electron beam will hit all these water sheet and treat it to convert in light or inorganic molecules. These are the some dye and textile effluent treatment using 1 MeV. So in dye water we have seen beyond 3.75 kilogray the color will be removed. Similarly in effluent water beyond 7.5 kilogray color will be removed. So the toxicity of these waters is tested by germination of mung seeds. Here are the different type of water has taken. It is tap water, it is control dye water, means this, and these are the various dose treated waters, and mung seeds has been deposited. Here after 2 days we have seen the germination beyond 3.75 kilogray is just like the tap water germination. But in case of untreated water, dye water, there is no germination, or for less dose it is also not appealing germination. So basically with delivering this much dose, the toxicity of this dye water has been reduced, and these waters can be reused for irrigation purpose. So electron beam is crucial to treat dye water to make it reusable in the field of irrigation by reducing its toxicity. Now I come to the solid waste management. A major threat in this direction is the used PCB, which is very a big challenge nowadays, and PCBs are normally used in mobile phones, laptops, smart televisions. So these are the composition of metal present in PCB and their respective natural ores. By this table, it can be visualized that the percentage of metal is very high in PCB comparative to their natural ores. So if a technology will come to recover these metals from used PCB, will solve our dependency on the natural ores, as well as it is make environment safe. These are the three components of PCB. It is base, fiberglass, and some polymer which acts as epoxy, and top layer is the metal. So these are the percentage of different items present in the PCBs. So if we recover the metal, then it becomes easily disposable items, and these metals can be reused. So challenge in recycling of used PCB, and a typical metal concentration in PCB varies in the range much higher than its respective mineral ores. Presently, the management of used PCB is through unorganized sector in not unscientific manner through crushing or burning, which creates environmental hazards also in the form of generation of noxious or harmful gases. So avoid this, a scientific manner has been developed to use accelerator to recover the PCB metals from these PCBs. So these are PCB with component and PCB after removing the component, and after removing the component we have to make some minor chemical application. Sodium hydroxide is provided to clean this PCB without component, and it looks like this. After sodium hydroxide treatment, we irradiate it with electron beam, and by this picture it is clear that the copper can be extracted by nails, piling through nails only, and this has been tested at different chemical labs, which concluded that 99.9% pure copper for reuse. It is the major technology development in the field of radiation treatment, especially using accelerators to recover useful copper and to manage the waste PCB. Polymer modification is another big area of electron accelerator applications. It is the most successful commercial exploited application using high energy electron irradiation, established technology for cross-linking and degradation without significant use of chemical additives. So the cross-linking of polymers or degradation of polymers are beneficial accordingly. In some polymer, cross-linking means increase in molecular weight provides thermal stability, restricted melt flow, solvent resistant, improved mechanical properties, less dielectric losses, and imparts heat shrink behavior. So these are the beneficial application of polymers after cross-linking using radiation source. Similarly, some polymer degradation means reduction in molecular weight or chain seasoning is beneficial for increase in solubility, increase in melt flow, easy to obtain microfine powder at room temperature. Ultimately, these two processes creates value addition to the material for various uses. One example is this is polythene O-ring, which is used as a vacuum seal in high temperature area like blast furnaces or engines of aircrafts and spacecrafts, but its softening temperature is 70 degrees centigrade. So after irradiation, its softening temperature will increase up to 280 degrees centigrade, So it can sustain the atmosphere where in blast furnaces where it is used having temperature in 240 degrees centigrade around. So this is a major application of electron beam to cross-link the polythene O-ring to enhance their thermal characteristics to utilize in high temperature environment. For wires and cable, these are the irradiation of cables as a polymers which is by this electron beam, and to improve the insulation and fire retardancy because the top layer of the cables are covered with these irradiated polymers. Similarly, automobile tires are irradiated to enhance their life as well as safety. The major encasing application of accelerator is its exotic coloration of gemstones. So these are the pre-irradiated and it is after irradiation. So the coloration has improved and various beautiful colors can be created of gemstones by using radiation. In the semiconductor area, accelerators are very successful, especially in case of ion implantation. So low temperature technique for introducing of dopant into semiconductor using accelerators is more flexible than the other method like diffusion. Semiconductor wafer act as a target and impurity in sorts into wafer provides excellent lateral uniformity which is less than 1%. So these are the ion beams and this is the semiconductor wafer, and the ion beam will hit and import in and diffuse in this semiconductor area with very excellent uniformity. So these doping process can be concluded with the help of ion accelerators, and this is one of the most successful application of accelerator in semiconductor field. Another application is to enhance the characteristic of power diode which is made of silicon by reducing its reverse recovery time. These power diodes are used as switching device in turbo generators and semiconductor device recovery from on state to off state. So it is reverse recovery can be defined as if it is current versus time plot. So in on state it is uniform, but when we switch off this is not suddenly fall and become zero and come in off state. It has some time delay and after that it will come to the off state. So this time delay there is loss of power which is very significant in case of turbo generators, or if we talk in terms of hundreds of kilowatt or megawatt. So this reverse recovery time has to be minimum for an ideal semiconductor. And after electron beam treatment, we have explored that to reduce the reverse recovery from 15 microsecond to 6 microsecond by imparting 4 kg of the dose. The exposure to electron beam introduces energy center in these power diodes that expedites the rate of electron hole recombination during the dynamic operation of the diodes. So the power diode irradiation at EVC is done for BHEL. It is exemplary example of successful partnership of research organization like BARC and industrial unit like BHEL. In the area of security application, electron accelerators are highly suitable for cargo scanning. So cargo scanning is similar to our body scanning using X-ray, but it requires very high energetic X-ray. So accelerator is required, and this the accelerated electron beam hit a target like tungsten to create X-ray, and these are the collimating units which slices the X-ray in the respective shape, and this cyan color is the X-ray beam which hits this object which is cargo moving in this traction trolley, and the transmitted X-ray will be captured by these detectors sitting behind this collimator in blue color, and that detector will provide the signal, and the image of the cargo has been created on a screen to see the movement of any objectionable object happening or not. It is very useful at border areas and at ports for safety point of view. This is a 6 MeV accelerator designed and developed by BARC in-house, successfully utilized for cargo scanning and also radiography to check the internal structured damage of bulk of material like some steel cylinders or some gas tanks, any much more. Indian cargo scanner facility at BARC. So in this, there is two type of facility available. One is called portal, where the source is sitting inside this box and detector is in this arm. So this source and detector combination is stationary and X-ray is firing in this direction, and the truck is moving through use of this traction trolley and crosses in this way. So while the imaging is done, the truck is moving through this, and detector will capture the transmitted X-ray, which is used to reconstruct the internal image. In the second case, it is the mobile unit, which is called the gantry based system. Here the source means accelerator is inside this box and detector is here. So source detector combination is mobile and the object means cargo is stationary. This mobile system is very useful because it increases the throughput, means the number of trucks scanned per hour is very high in this mobile unit comparative to this stationary unit. Both these two are successfully working at BARC. Now I come to second part of the safety aspects. It is dual energy. So why dual energy is required? Suppose we have four materials which is unknown and we want to identify it. So if I use one energy, so say high energy of 6 MeV, the materials image will like this, and if it is low energy, since 4 MeV, the image will come like this. So X-ray is chemically blind, so we can't discriminate between these type of materials just hitting one energy of X-ray to that material. But if we go for dual energy, means high as well as low, so this is possible if we have the dual energy accelerator, means the accelerator which can produce one energy in one pulse and another energy in another pulse. So high, low, it is interlaced mode operation. So if we use the dual energy, the image will be the material will be discriminated because the interaction cross section of both the energy are different and depending upon their atomic number Z value, and based upon the Z value we can identify the material. So actually with the help of dual energy we can say which type of materials is this, and for safety angle only these four bands are important because this is material 1, it is organic band up to Z value atomic number up to 10. This is safe, which is called light element group when Z is 11 to 20. It is inorganic material. Most of the weapons are made from this band of material where Z value varies from 21 to 60, and these are nuclear category beyond 60 atomic number. So in this way, from safety angle, only these four bands are important, and if we are able to discriminate the material based upon these either one of these band, it is successful on safety angle. So our aim is to discriminate the band, what if it is actual material or it is not or it is actually a dummy piece. So based upon the dual energy accelerator, with these slides, I can show the comparative image. This is the single energy 6 MeV accelerator. This is dual energy 4 MeV. So the image of cargo is this. Here there is no signature of the material, but here we can see the different type of materials using dual energy based upon their atomic number discrimination. So this looks like both looks like same, but actually it is lead battery, it is steel plates. This is also looks like steel plates, but it is actually oil. These are sands. So based upon the dual energy, we are able to discriminate the material based upon their atomic number. So accelerator for power generation, and it is in form called accelerator driven subcritical system, ADSS. So global issues of nuclear energy. So burning legacy of the past, it is reducing cost of ultimate waste, better use of resources, and enhance the safety. These are the common needs for power generation today. In case of nuclear power generation, the steps are like this, which is basically the recycling stage. It is mining, then conversion of the fuel, enrichment of the fuel, fuel fabrication, which is used in the nuclear reactor for electricity generation, and the spent fuels are reprocessed and sent it to geological waste depository and recycle it. So this recycling is important, as well as this enrichment of the fuel is also very important. So this enrichment can be possible with the help of accelerator also. How it is possible? So it is energy amplifier topology. In November 1993, Italian physicist, who is the winner of Physics Nobel Prize in 1984, suggested that a first thermal neutron energy amplifier system, which is based on the thorium cycle, with a view of energy production. As it became clear that in the Western world the priority is the destruction of nuclear waste, the system evolved towards that goal into fast energy amplifier. So this energy amplifier is used in two ways. One is nuclear power production using thorium, and incineration, destruction of nuclear waste, which is a very big challenge of long-lived waste management. So this has a appealing concept of Indian scientific community to start accelerator-based reactor system to utilize the thorium, because thorium reserves in India is very high, which is 16% of the total world reserves. The accelerator driven energy amplifier. So what is this? Here it is a cycle, which is the it is accelerator which hits the target, converts into the energy, and this energy is 240 megawatt. Suppose 180 megawatt is used for the normal electricity used, and 60 megawatt out of this is given to the accelerator, because it is very high power accelerator. Again this accelerator will hit the target and generates 600 megawatt, which is converted into actual electricity of 240 megawatt, and the cycle will remain continue. So this is the theory of accelerator driven energy amplifier, and in each cycle energy will increase in the form of suppose 180 megawatt multiples. So in this way this concept has been started, and BARC utilized this concept and start a very challenging job in the direction of accelerator driven subcritical system, which is based upon 1 GeV proton accelerator system. So it is proton accelerator. After that this hits some target which is made of lead and bismuth, which generates neutron, and that neutron will utilize to convert the thorium in useful fuel for nuclear reactor to generate electricity. So first is energy amplifier, efficient use of thorium resources, and transmutation of long-lived radioactive waste. Transmutation means conversion of long-lived radioactive waste into stable or short-lived radioactive waste. So accelerators are very useful and in futuristic in the field of power generation. Accelerator for basic research, radiation sustainability and performance test of solar cells for space applications, because radiation, a big amount of radiation can be delivered in very short time to check the radiation sustainability of different components which are used in high radiation area for long time, like space, nuclear waste depository materials, electronic items to be used in high radiation fields like nuclear reactors, communication system used in nuclear reactors. So all these radiation sustainability tests and their performance variation as impact of high radiation field can be tested by accelerators before using it in actual field. Radiation detector development area is very suitable for accelerators utilization. Radiation shielding studies, here accelerators are beneficial, and development of new materials for radiation shielding. Upgradation of regulatory guidelines, because accelerators are very safe, having switch on and off facility. So based upon that, iterative experiments can be carried out to upgrade the regulatory guidelines. Now I come towards the last of my talk, and it is the footprint of accelerator. So if we go for an electron accelerator of 10 MeV, only 20 meter by 20 meter space is required for actual site, and it is, if vertical mode, it requires two-story buildings. Is first floor where accelerator is located, and is ground floor where irradiation area or cell area is located. So product will enter through this, and processing radiation treatment has happened here, and through this route it will come out. So it is continuous process of entry and processing and exit of the product. In second case, it is single conveyor system can be used. It is horizontal profile of the accelerator. Electron beam is firing in this direction. So product is coming through this, and these boxes are processed in front of this accelerator and come back. So this is batch wise irradiation processing. At the time the one batch is processed, another batch will be ready, and it will go when this will come back. This slide is courtesy from radiation processing facility of RRCAT Indore. In this way, we have seen that how this machine accelerator is useful in our daily life, and it touched all the domains of our activities like waste management, electronic waste, wastewater, dye waste, as well as industrial waste, as well also for municipal waste, medical applications for sterilization of medical products, and cancer therapy and diagnosis of cancer, food preservation, research to generate various nuclear data and other scientific requirements, security application as cargo scanner or semiconductor performance upgradation, and many more. So keeping in the mind of broad applicability of accelerators, BARC has given its electron accelerator technology on its website for transfer. Anyone wants to take this technology for mass production and actual utilization of accelerator can visit this website or write email to any one of these. With this, I conclude my talk with the hope that accelerator will utilize more and more for betterment of societal needs and explore also the untouched scientific fields. Jai Hind.
So, I hope you all enjoyed this lecture. Do not